Good afternoon, ladies and gentlemen. Welcome to today's Open Classroom webinar. I trust everyone is safe and well, and that Level 2 Stage 4 is not affecting your... Uh, hmm, maybe let me leave that there. In today's webinar, we welcome back Andrew Cole, who will be covering the draft expert functionality included in the Survey and Terrain module. During Andrew's presentation today, please feel free to use the text chat service on your GoToWebinar app to ask us any questions you may have during Andrew's presentation. So, good afternoon, Andrew. Please take it away.
Hi there. In today's Survey and Terrain webinar, I'm going to be looking at the observations and figures functionality. And I'll also be looking at the very useful draft expert functionality available in Civil Designer. With the observations and figures, you have an easy to use interface for managing your total station records. Once you have created an observations and figures file, you can then load all your readings from your total station or data logger into Civil Designer, effectively creating a database that can be used for various survey calculations. So in today's webinar, I'm going to be using the observations and figures database to perform both a double and reverse polar calculation, as well as a Travis and Tacky reduction. Okay, to start with, I'm going to go to my project settings, so file project settings, and I need to create an observations and figures file. I've already got a terrain file that I've created for this project, and I'm adding the observations and figures file. So as with any new project file that you're creating, you have to give it a name. It'll ask me, do I want to create that FD8 file? Yes, I do. And now we have the observations and figures file that we need. I just need to name my terrain surfaces. I'm going to need to have one for the control, so the outside control, and then additional surface for the local stations. And then thirdly, for our tacky survey reduction, we're going to create a separate surface. Okay, so those are the three surfaces that I'm going to be using. Okay, then I need to import my outside control, so it's just a normal ASCII single file import, and it's that control that file. Just have to name the columns, so it's my point name, the y coordinate, x coordinate, and the z coordinate. You can save those settings if that's going to be the standard import sequence. Okay, and that's going on to that outside control surface that I just created in the display settings. So there's my outside control, there's trig beacons, and my control points. Okay, so we're focusing in on this control 1 and control 2 points. Okay, so now we're going to open up the observations and figures dialog. So it's file observations and figures. You've got a stations and a figures tab. The figures section can be used to generate your SG diagrams, but in this case we're going to be importing our data, the total station data, and in this case it is a Booker Brown file, that ODB file that we're going to import. And there we have all the stations from our survey loaded. You'll notice that control 1 and control 2 have a different icon. That just means they are coordinated and can be oriented. You can manage your job numbers or group your jobs differently. At the bottom here, the default name is job 1. But you can add new jobs and delete as and when needed. Okay, so we're going to do control 1, and as I said, it's coordinated, so we can orient it. So the orientation corrections, I'm just going to disregard or disable that third one to control 2, and you can see the orientation correction column. And then control 2, we can also orient that, and those two are acceptable. And you see the orientation correction for control 2 as well. You can just double click on the actual station name if you want to view the observations from that particular station. And you'll notice that we have quite a few observations at station S1, and then station T2 would also have quite a few observations, so those would be used for our tachy reduction. Okay, so just to double click on the actual station name to view those observations from that particular station. Okay, so I'm just going to save the observations and figures into my project file, and then we're going to move on to the actual calculation. So in the survey mode, we're looking at the calculations pull-down menu. So we're going to do a double polar and then a reverse polar. We're also going to do a tachy reduction and a traverse. Okay, so to start with, I'm going to do the double polar. So it's calculations, double polar. So we're using this polar calculation to calculate the coordinates for the local station S1. You can load the information from the observations and figures database. We've got some default names given for the stations. So our first station for the polar calculation would be control 1. So we're going to load that in. So it's control 1, the station that we're looking at, and the observation that we require is the observation to S1. Once you've selected S1, you can see that the target point has now been populated as S1 from control 1, and then the second station for our double polar needs to be loaded as well, and that would be control 2. So station control 2, and we've got the observation to S1 from control 2 that we need for the double polar. So I can load that in, and we'd like to create this new target point S1 on destination surface, the local station, so my DTM surface number 2. This is a heighted control that we want, so we're going to include the elevation in this calculation, in this double polar calculation. There's a preview result checkbox that we can preview it before we process. So you can see in this output preview dialog, you'll get a preview of those coordinates, the Y, X, and Z coordinate. And that point is then inserted into our DTM on that surface 2. Okay, then moving on to the reverse polar calculation. With the reverse polar, we're going to be working out the coordinates for S2. So our station point is what we start with, and we need to load S2, the observations from S2. And the measurements at S2 to control 2 and trig 5 are geometrically the best combination for our reverse polar calculation. So near station, we've loaded control 2, and then the far station would be to trig 5, the observations at S2 to trig 5. Okay, we want to create that new point on surface 2, our local station, and we also want to include the elevation in the calculation to get a heighted control point. Remember, we can preview that as well before we actually add it to the surface. So we get a preview just to verify the result, and then we can go OK and close the dialog, and you'll see that S2 has now been added to our surface. Okay, then moving on to the traverse, the reductions traverse calculation. Instead of entering the traverse measurements manually or loading them from a file, we can use the measurements from the observations and figures data by using the traverse assistant. So you would have to define the route of your traverse, and in this case it's from S1 to T1, and then to T2, and then back to S1, so it's a circular traverse. Okay, so that would be our route. S1, T1, T2, and then back to S1 with a circular traverse. Okay, and then we'd have to add all the contributing traverse measurements from each station. So we have to add the orientation at S1 and the foresight to T1. And then at T1, we're going to be loading the observations from the observations and figures database. In this case, the orientation to trig 5 and 6, the backsight to S1, and the foresight to T2. Okay, then at T2, we also need to load once again from the observations and figures database. So it's orientation to trig 2, and then your foresight and backsight. And then finally for S1, we also need to load the orientation to trig 2 and 5, and then the backsight to T2. Okay, so there we've got all our observations from the various setup stations along our traverse route. And if I click OK, you'll see that the field book is now populated. These symbols, the curly bracket is a setup station. The percentage symbols are the orientating rays. And then the U would be an unoriented traverse observation. So using the Traverse Assistant and the observations and figures database, it's been a lot quicker to populate our Traverse field book. And then it's just a matter of reducing our traverse. You have an option of a flat, slope, and full traverse. The flat one only uses horizontal distances. The slope traverse takes the slope distances with your vertical angles into consideration. And then the full is the slope traverse with vertical angles and the corrections for your map projection. So we're going to run a full traverse, and we're dropping those points onto our surface 2, the local station. So we're calculating T1 and T2. No need for any outside orientation, as we've got enough orientation already. And then just yes to do the final adjustment, which is the bow ditch adjustment. No need to save the data, and then you can see those new points T1 and T2 have been added to surface 2. So the next thing we'll look at is a tachyreduction, but before we get to the tachyreduction, I'm just going to go to the observations and figures to sort out the naming convention, so the names and the tags or codes. So some total stations or data loggers store the point name as a numerically incrementing value and have the descriptive name as a code or a tag. In Civil Designer, we store both the name and the tag. So you can see over here, we've got numbers 171 to 181. And in Civil Designer, you have got a right-click option there to swap the name and the tag. So we in fact want the names to be all in the name column. So I'm doing that for T2, and then we'd also need to do that for S1. Remember, we had quite a few readings from S1. So in this case, we've got from number 1, which is the numeric code that they've used in this data logger, right down to 170. So I'm just going to swap those so that the name is what we could use when we import that data into our Civil Designer project. So we've got the tags, the numbers on the tag column now, and the names in the name column. So this is the data we're going to be using for our techie reduction. Okay, so this is the ability that Civil Designer has, so you can actually do that in this observations and figures database. Okay, so I'm just saving that with the changes that I've made in that observations and figures file. Okay, so then moving on to that reductions and the techie reduction. And once again, we're going to make use of that assistant, the techie fieldbook assistant. Just to mention as well that the swapping of the name and the tag columns can also be done inside the techie fieldbook. Okay, so I'm defining the stations for our techie. So that would be S1 and T2 that need to be moved from the available stations across to the destination list side of this dialog. Okay, and then the actual techie and orientation measurements for these two stations now need to be loaded. So I'd select S1 and then click on the load button. And we once again reading from that observations and figures database. So the observations from S1 would be trig 2, trig 5 as the orientation measurements, and then the EDM measurements would be from 1 to 170. So I've added the measurements from 1 to 170, and then just trig 2 and trig 5 need to be added to the observations list from S1. Okay, and then for T2, I also need to load those observations or measurements. So here we need from 171 down to 181, reading from the tag column, and the orientation for trig 2. Okay, and then just confirming that we've got the orientation to the trig beacons for S1 and T2, and then we've got all our EDM measurements for our techie survey from those two stations. You can see there the techie fieldbook has been populated. Once again, curly bracket represents the setup station, and the percentage sign is the orientating ray. Okay, so our fieldbook is populated. We just need to reduce our techie. We can accept that orientation correction. In this instance, we're not adding a suffix to our reduced points. We're storing these new points to surface 3, the techie surface. And we've already calculated the coordinates for S1. So that's been automatically populated. The orientation corrections for T2, once again no suffix, and storing it to surface 3. So we can close the techie fieldbook, no need to save that. And you can see in the background that those points from our techie survey have been added to our DTM surface number 3. I'm just going to use the control center survey section just to switch off the visibility for surface 1, which was our outside control. And then probably also need to switch off surface 2's visibility as well. So just going back to the survey and terrain section of the control center and switching off the visibility of surface 2 as well. So there's all the points from our techie survey. So next up, I want to move on to the draft expert, which is under Tools, Draft Expert. And in this case, we want to use the point-to-point method. So I'd like to join up these BK points to define the road with the line, but there are no settings as yet for BK points. In fact, there are no settings in the draft expert. So you get an option then to define your own settings, which actions you'd like to have take effect with the BK points. So in this case, I want to draw a polyline, a 3D polyline, and I'm going to drop this onto a CAD layer. If you type in the layer gets added to your layer settings. And then just a color for these 3D polylines. Okay. And now I can click on the next BK point and you'll see that the lines are then drawn in. Just to tidy up this survey and just make it a bit clearer, I'm going to use the name filter and only allow the BK points through. Okay, so just joining up all the road points. When you get to the end of a sequence, you can just right click to finish and then just start the sequence again. Okay, so in this case, it's only the BK points that I'm joining up. Okay, and then I can clear the filter. Well, as soon as I escape out of that function, the filter is then reset the ER name filter. Okay, then back to the draft expert. I'm going to go to the settings just to verify. So in the draft expert, we've got a few default names and actions that we load, and then we've added now the BK to all those default settings, the BK actions for all the BK points. And you can load and save those settings to file. So you can save it to a file and load it if needed. Okay, then I'm just going to save my project at this stage. Save those changes to the DTM file. Okay, then we want to use the draft expert. I'd like to draw in some CAD work. So back to the draft expert, the point to point. And in this case, I want to do the telephone poles. So just setting the names for the TP to only be visible. So only the TP DTM points that we've got from our techie survey. And you'll see when I click on one of those TP points, no settings as yet in the draft expert. So in this case, we're creating the settings. So generally you would set up your settings before the time, but in this case, I'm doing them as we're going along. So for this TP point, I'm adding a radius circle. And I'm creating a new layer called features, which will be added to my layer settings. The radius I'm going to leave at 0.5, and then we want to put in a label. So we just need to change the labeling to true. Yes, we want a label, and this will be the telephone. So we're adding that telephone text to the radius circle. So you've got a radius circle diameter of 0.5, the label height for our text 2.0. So I've already clicked on that first point and then click on the other two TP points in our survey. Just reset the name filter and you can see all the points again. So the draft expert is there to automate your CAD work for the topographical features in your survey. Just going back to the draft expert settings, and you can see the two new points that we've added to the setting. So in this case, I'd like to add with a right click to add additional point with its own actions. So this is going to be the MH, the manhole point, and I'm duplicating that from my TP point. So bringing those settings that I've already got from the TP point across, which is the radius circle of 0.5 with the text, which I don't want to be telephone anymore, so I'm going to change that to manhole. And I want to read in the cover level as well from the Z value of my DTM point from our Tacky survey. So I can right click and then read in the Z value of that DTM point. There are options to read in the X, Y, and Z coordinate or the point name as your text value. Okay, so let's try out that manhole action from the draft expert. So I'm going to go to Tools, Draft Expert, once again using the point-to-point method, and then just using the ER name filter to only allow the MH points through our filter, just S to refresh, and then just zooming in here on one of the MH points. So we should see the radius circle and the manhole and the cover level being read in. Okay, so I'm not going to do all the MH points, just doing the one as an example. And then finally today I just want to add settings in the draft expert. So I'm going to the draft expert settings and I want to add some actions for that concrete block wall. So it's the CBW point name. I'm not going to duplicate it from anything, so I'm just going to do brand new settings or actions for this particular point. And once again, a 3D polyline. I'm going to put it onto the structures CAD layer and change the color. So in this case, for the polyline, we want it to be a closed polyline, so just changing that to true. And we want to hatch this block wall. So it's a structure. We'd want to hatch it if the polyline is closed. And we're selecting that NSI 31 diagonal hatch pattern. We've got a number of hatch patterns to select from. Okay, so going back to my draft expert to the point-to-point method and just zooming in down at the bottom here, we've got this concrete block wall. And you'll see when I've joined up these points and I right click and finish, Civil Designer automatically will do the hatching for you. Okay, then just going to the settings, the draft expert settings here on the command line, and just checking those new points that we've added, and just reminding you that you can save these settings to an XML file, which you can then load and use for future projects. Okay, so build in your company standards and reuse them when needed. So as you can see, the draft expert is quite a useful function. And if you want to see more detail on the draft expert functionality, we have got a video specifically about the draft expert on the civildesigner.com website under the FAQ section. And that's me for today. Until next time, cheers.
Thank you, Andrew. That was very interesting. And thank you to all of you who attended today in these trying times. Please remember that if you'd like any further information with regards to Civil Designer, please use the email address listed on your screens right now. Please also remember to request a Civil Designer version 8.4 download link from our website's homepage if you have not already done so. Once again, thank you for your time today. Have a great afternoon, weekend, and goodbye for now.